Hi everyone, welcome to this week's tutorial, which is all about an introduction to Jamovi. I don't know what you can see, whether you can see me, whether you just see the screen on the recording. I'm sure people online can see me okay. This is the first year that we're doing this online series for the tutorial, so that it's live coding in action. Why do we not do it live in action? Because coding is typically very messy. So you often get lots of mess that occurs in that process. But in any case, at least this will be a transparent sort of documentation of that process. So you'll see it all in action here. I'll be flicking between screens and showing you Jamovi output and the slides where possible. And the slides and this recording will be popped onto the Canvas site for the week, so you can review that. So let's get started. So with today's tutorial, we're going to be focusing on like an introduction to Jamovi. So this includes importing data, inspecting the data. We'll talk a bit about syntax and R, data shaping, and saving your work. So hands up in the tutorial. Who's used Jamovi before? The hands function? Yeah, no. Excellent. Got 3 out of, yeah, excellent. And if you don't see the function, it's down near the video. So if you see the video and then the hand, that's that. So, okay, so sort of half of you have used Jamovi, maybe half haven't, or perhaps from that data, maybe half don't know where the hand function is. That's okay, we'll work it out. So if you have used Jamovi before, this will be hopefully a pretty relaxed cruisy tutorial for you in the sense of navigating Jamovi and understanding how to use it, or a good refresher. But you'll still learn something new because I'll show you the back end of Jamovi and R and how it works and operates and built on R. If you haven't used, don't worry. I'm going to take you through the basics and build you up from there so that you're able to do the assessments, essentially. So the core skills that you'll be learning today in terms of importing the data, inspecting the data, doing data shaping and saving your work are all things that you'll be doing for the assessment of the survey data, of collecting that data and putting it into the spreadsheet and submitting that, in addition to the lab report, in addition to the final exam. So all these Jamovi skills are going to be important across those assessments, and also important for your overall research and being able to do analyses. So that's what we're going to be covering today. So what is Jamovi and why do we use it? So Jamovi is a software used for statistical analyses. It's not SPSS. SPSS was sort of it's still used to this day, but less so because it's so costly. So Jamovi is free, which is the major benefit of it, in addition to the fact that it's constantly being updated, much cleaner, simpler, and powerful. And it's sort of like a gateway drug to R. So, oh, excellent. So Emery said you transferred to UC and you're excited not to be using SPSS anymore. This looks way more intuitive. Great. Good to hear, Emery, because there's a lot of benefits. In addition to the fact that Jamovi is free, it's, yeah, as I was saying, it's sort of built on top of R. So it's like a gateway drug to being able to use R. And so I'll show you what I mean by that in this tutorial. I'll show you how to sort of map it onto R. So as Emery said, so other institutions may still be using SPSS. It's very commonly used, but it's just very costly. So what does it mean in the fact that it's constantly being updated? Is that depending on the version you have, you may see slight differences in your Jamovi. So for example, I may say there's something here and this is how to navigate to it, but on your version, it may actually be somewhere slightly different, or maybe called something different. These are just nuances within the versions. We'll work it out. It's just the nature of it. And typically, if you say, for example, you've downloaded Jamovi in an old unit, one of your first year stats units, and you haven't touched it since that unit, it's a good practice to update your version of Jamovi. And so often the rule of thumb I use is whenever I do a big project or big research project, that's when I update my version of R. And similarly, that's what you should be doing with Jamovi. Full disclosure, I think I said this in the intro lecture, but I don't use Jamovi outside of teaching you how to use it. So I'm also rusty around the edges, but it's certainly just a good platform to being able to use. And hopefully once you understand Jamovi, you get a sense of, well, you can apply this to different software tools as well. But it's really point and click software, so it should be intuitive to some degree. There are instructions for downloading it on Jamovi. I mentioned before as well, we started the recording, that if you type in Jamovi in Google, it'll take you to the Jamovi page, and then you can download the software. It should auto detect what your computer has, whether it's Linux or Mac or Windows. But I have detailed instructions on Canvas for you, and there's a free textbook as well as a user manual to help you get set up and started with downloading Jamovi. So Jamovi is a useful intermediate ground for being able to do analyses. Excellent. So let's get started. Any questions at all about Jamovi? No, if you have any questions, just pop them in the chat. I'll keep an eye on that, and that's a nice way to sort of integrate what we're doing. Thanks for the thumbs up, Mel. Love the feedback. We're doing, this is our nighttime statistics. This recording is 5:30 to 7:30, so we're really in the nighttime mode of data coding and statistics. So good to keep the vibes up. So with this, let's get into importing data. So the data set that you can find is on Canvas. Let me pop that up for you. So if you go into Canvas and you go into week 2, you should be able to find it. And so in Jamovi, what you need to do is to click the 3 horizontal lines. So let me do that here. I'm sharing my screen, so that should all work out well. So let me go, do I have Jamovi? No, I don't even have it in my toolbar. Okay, let me go Jamovi here. Pop it in, boom. Okay, so I got Jamovi up. It does show you the version here, which is nice when you load up Jamovi as a version. You can also, I think, click these 3 dots and it gives you the version. So if you've imported your data, this will go away and then it'll show you the version there. So that shows you the version that I'm using and using for these slides. So I'm going to click these 3 horizontal lines in the top. So if you're following along online, hopefully you have Jamovi up and running and you're clicking these 3 dots and you go import. I don't know what the difference between special import and open is, but I like to think special imports just because I'm special. So I'll just put that in there. And then I'm going to go into survey, research, and design. This is where I've saved the data file. So I'll just pop it in there. And there's my data file. Wherever you save your data file is where you should be clicking to open it. And then I open, and I get an import successful. Let me make this nice full screen for you guys here. Can I make it bigger? No, okay, sorry. I cannot make it bigger. I thought I could zoom in somehow, but hopefully that's detailed enough. Is there any way? Oh yeah, here, zoom. Okay, so there's the zoom function. So now you can see, here's my data file in Jamovi. You notice that I have these like 3 columns here. You may not have that if you just open the data file, the .omv file, and your computer enables you to open Jamovi automatically, or tells you to select a Jamovi. But I have this because I opened Jamovi first and imported data. So if I want to make my data nice and clean, I just click those columns, right-click, and delete variables. And say OK. And then boom, we've got our data set. Yeah. So I'll use that button a lot. Okay, so that is Jamovi there. Can I do full screen? Yes, excellent. Okay, so that's Jamovi, and we've imported the data, and I've shown you how to delete those variables A, B, and C, and that's how that works. Any questions about any of that? All good. Hopefully everyone's following along. If you need me to explain something, just pop it in the chat or re-explain something, or if you're stuck, just let me know. Like I was saying before we started, this is the first year we're doing the online version of these tutorials, so it's a new experience in terms of doing data coding online, but hopefully it allows for people who are working to be able, no worries, Mel. I know people are working and full-time, they may be working, so that's why these are here, to allow people to still have the in-person experience, but just, I guess, online in some ways. Okay, so now let's inspect the data. So what I want you to do is check the default missing values. So to do that, you go into Jamovi, click these 3 dots in the top right, and you check your default missings. So this says NA. So what that means is any value that is NA in the original data set will be blank. And so this blank cell is just an NA value. This blank cell is an NA value. So that's that there. Yeah. So that is the default missings, and that's how you check them. You press the 3 dots. So people may have different ones. They may say the default missing is -999 or -99, and so that will be blank cells, but that just shows you what it is in Jamovi. Cool. So it depends how it's coded. So for variables, to understand more about the variables, we're going to double-click the variable names to see more information. So let's say pop you life expectancy. It says life expectancy M, and it gives us some information. So it says nominal, it says integer, it has missing values as empty, and it has what it says as levels here, right? So before we go further, I mean, these tutorials are really the practical application of the theory in the lectures. So we won't always, if there's things that it covers, like in future tutorials when we're talking about correlations or multiple linear regressions, there just usually isn't the time to rehash the theory in a lot of depth. So what this tutorial and all of that content is focused in the lecture videos that you can rewatch if you are struggling with any of the concepts. But all of these tutorials are really the mechanics of how to operate within the Jamovi environment. So it'll show you, what I'll be showing you is really how to do what you need to do. But if you have questions as to what is a nominal and what is an ordinal, these are things that you can rewatch in the lectures. But in saying that, just to check in and see how people are going, what is a nominal variable? Do people know? Feel free to turn your mic on or pop it in the chat. What makes something nominal? Category variable that has no order. Perfect, Luella. Categorical like country, yeah, excellent, Mel. So, which has country is a good example because you could say Australia here, like in this example, right? So, we have all these countries. These are all nominal variables, but note that they've measured the type as ID. But they're nominal variables that have no order. So it's a categorical variable that has no order. Excellent. What about ordinal? Categorical, but with ranking. Excellent, Mel. Emery, medal goals, silver, bronze. Yeah, that's a good example. Luella, it conveys order, but not any interval between positions. Yeah, so it gives you a sense of what the order of the categories are, but it doesn't give you a sense. There's no meaningful difference between the groups in terms of those categories. Numbers in order, yeah, and there's no true zero as well. Yeah, that's right, Alice. Excellent. So that's and I get a good sense that you understand what these are because of your responses, but we'll ask anyways in terms of interval. So the interval, what does that do in difference between interval and ordinal? So ordinal has the order there. The interval has what? Close, Mel. That is actually ratio. So ratio is where you have the true zero. Oh, perfect. Yeah. So you have the position and you have the difference between the positions is meaningful, but there's no true zero. Excellent. And then when you have a true zero value, then it is ratio. For example, like weight or height or age, all of those have a meaningful zero, and that's ratio. Excellent. Very, very good. So those are the different categories. And so in the measure type, you'll notice that it has nominal, ordinal, and it has continuous. So if it's ratio or interval, it doesn't really mind. It just puts it into continuous, and that allows you to do the analyses you need to do. Keeping in mind, if you don't select the right variable, you won't be able to do the required analyses. So if you're selecting ordinal for a continuous measure and you're trying to do an analysis, you'll encounter errors. So it's really important, first step, to be looking through each of these measures and making sure they're coded correctly in terms of their measure type. And then we have something called data type here, integer, decimal, and text. It just tells you what the type of data is. It's auto-generated. I worked out today what the little a means here because a student in my morning tutorial informed me once they worked it out, which was the fact that it actually reflects the text value. So if you change this to integer, the a goes away. If you put it into decimal, it's not there, but then if you have text, it's there. So these sort of little symbols give you a sense as to what the measure type is. So here I can tell this is continuous because of the ruler. Here it's well, it's ID because it's like a blue sort of indicator. Here with the Venn diagram, it's nominal. And do I have an ordinal one? I do not. So I'll change this to ordinal, and it gives you the bars. Yeah, that's ordinal. So I'll put it back there. Excellent. So that is everything with the measured types. And we've talked about the default missings. We've talked about clicking on a variable to see more information, which is what we see there. And then, oh yeah, say you're here and you're like, what do I do? How do I get rid of this variable? I don't want to see this anymore. You just press that up arrow. So click that up arrow and it all goes away. You get your nice Jamovi version again. Excellent. Now let's talk a bit about doing some analysis. So let's do some descriptives. So this is one of the most critical things you'll be doing in your research careers and in this unit, because it's the first step in terms of understanding your variables and understanding how they're distributed and what analyses are appropriate. So we'll go to do descriptives, we'll go analyses, exploration, descriptives. Yeah? And then you just pull the variables across that you need. So my questions to you are, I should have some questions here. Yes. What is the distribution of life expectancies? Inspect life expectancies in females. That's what the life expectancy F is for. And males, life expectancy in males. Generate frequency tables, inspect statistics and plots menu, and generate plots. I'm going to give you a minute or two. Have a go at that, and then we'll regroup to see how you went. Let me know in the chat if you're having any difficulties. So have a click around once you put those variables in. Can you find how to generate frequency tables, inspect statistics and plots menu, and generate plots? Yeah. I should say I think I said it already, but in case I didn't, these slides are going to be made available with the recording at the end of the tutorial. So you'll have access to all of this. How we go? All good? Hands up if you're done. Sorry, I raised my hand. That was my bad. Excellent. Does anyone need more time? Hands up if you're done. Just pop your hand up for me. And that way I get a sense of who's finished. Excellent. Okay. Looks like people have got a sense of it, so let's do it together. If you haven't, don't worry, we'll have to go together. So you go into here, and you go life expectancy of females, life expectancy of males. Here it is, and it generates the descriptors for you. These descriptors are automatically generated, right? So it chooses mean and median for you. If you want mode, you can select that, and it puts it in there for you. It has minimum, maximum, standard deviation. If you want variance, you can select that. It'll put it in for you. And interquartile range. So you can modify what is viewed there, right? Skewness and kurtosis statistics, all of that sort of stuff. So that is there. If you want frequency tables, you click frequency tables. It's like that. And it gives it to you for each variable. So the frequency table here is life expectancy of female, and it shows you how many countries, because that's what the data set relates to. Let me see if I can pull this across. Each of the different countries for what is the life expectancy of females in those countries, and that's what we see here. And so for some countries, there's one country with 43 for life expectancy of female, 2 countries with 44 of life expectancy of female, 2 countries at 45, and it goes on as you go down this. What I want you to do really in this course, beyond being able to do the mechanics of these analyses, is actually be able to understand what you're generating. And so every time you're generating something, whether it's something as simple as a frequency table or descriptives, really take the time to say, okay, what is this table showing me? What does each of these cells, what do they mean? So for here, it shows you that there's 109 rows in each of these data, and then we can scroll down and verify that. Yes, there's 109 observations. There's no missing data for these variables, life expectancy of male and female. There's we can see the fact that the mean life expectancy is 70 for females and 65 for males, so it's higher in women than men. The medians here, standard deviation, and we can see the same thing with frequencies, right? We can see what the percentage of total is for each of these groups, and also what the cumulative frequency is, which shows here almost 1% of the data has 43 as the age of life expectancy for women. And as you go down, you could say things like, oh, well, 50% of the data have mean age life expectancy of women is 74 or less, right? So actually using the data that you have to articulate a story, and that's the beauty of statistics, really. You're able to articulate the story behind the numbers, right? Statistics allows you to make meaning from the numbers, and that's really where using these sort of tables and figures that we're going to do allows us to do those things. Excellent. So I've done that, frequency tables, I've done my descriptives. Now you can do the plots. So you just go down and you can generate whatever plot you like. I'm going to generate some histograms. And here we see here, right? So who wants to have a go at describing this histogram for me? Does anyone want to have a crack? How would you sort of extract some meaning? What is this histogram showing you in terms of our data? Any ideas? Life expectancy is around 80 in most countries. Yeah, that's excellent, right? So that's a good observation there, Mel. So what you've identified there is the mode, which we'll cover in more detail next week, which is the most common score. So you're saying, oh, okay, so the most common score is around 80. Excellent. So that's good to see. And that could be corroborated as well through our frequency tables. We would see that life expectancy of females, that's quite high there. Where is it? It's probably a cluster, so it's probably around, oh, that's males, that's why it's confusing. Yeah, here. So it's probably this cluster that we're seeing in that bar chart here. Excellent. What else can we see here? Is it negatively skewed? Yeah, it is negatively skewed. We'll cover this again in next week's lecture, so don't worry. But really, what I'm sort of trying to get people to see from this is that most of the data, which you've said correctly, Rochelle, is clustered around the top end here. So most women are living in this bracket beyond 70 years of age, right? So this is a visual representation commonly in the 70, yeah, excellent, Mel, yeah, so it's commonly in the 70 and 80 range, whereas in men, there is a bit more of a spread, and it's probably in the 60 plus range. So this is essentially your data in graphical form, and so you're able to make sense of these numbers using these histograms, or these these histograms. So it's really useful to have a look and sense of your data from here. Excellent. Okay, well done. That is that. We've generated plots. Now we're going to APA format this table. So what do you do to APA format your table? You right-click your table. So here, I want you to all do this with me. So you right-click, you go copy, and then you open up a document to Word, which is this one here. And you can see I've done this a few times already. So here is our copied data table from Jamovi. Now we can APA, it's not in APA format, but we have to do a few things to make it APA format. So first is we can select the entire table, this button, and we can change the font to Times New Roman and the size to 12. Sorry, it's a bit small. Whoa, that's a bit big. There you go. So the size is 12, there you go. And then there's other things that we can do to make it APA formatted, which is which is what the top one is here. We need to give, we need to remove this bold fonting here. So let me remove that. We need to then give these variables readable names. So I'll call it life expectancy female and life expectancy male. Expectancy male. Yeah, and then you'd want to do something like give it a descriptive title. So female life expectancies across countries there. And then what you would have, which I don't because I've done this once already, but you may have a really heavily bolded bottom line. So to fix that, you click this button here, which doesn't always show unless you're sort of navigating near it. You click this 4-arrow button here, or cross button there, highlights the table, then you go up here and you select bottom border. And that should take away the heavily thick bottom border that you have. And then you've got a nice APA formatted table, yeah? With saying the number of country work, oh, in terms of where? In terms of, feel free to expand, Annalise. I'm not sure, number, as in like in the N instead? The description, number of country. Well, this table in particular shows you more than number of country because it actually shows you about these two measures, right? So it shows you, so actually I've written, it should be female and male life expectancies across countries. So your description of the table should really showcase what is the information within this table. And so that's sort of what you'd be after there, yeah? Excellent. So that is that. The reason why I wrote life expectancy female is because in this example, I just used the females there. Excellent. So that is everything to do with APA formatting. I should say, by the way, that when it comes to APA formatting, the key thing is to use the guidelines that are there in your formatting. They do change and get updated, and really, if you can find the guideline that justifies what you should be doing in terms of APA formatting, that's key. The reality is, even I, as a researcher, when I submit my paper to a journal, if it's a psychology journal, it'll require APA formatting. If it's a neurology journal or other journal, it may require a different type of formatting, like Chicago or whatnot. And so I don't know all of these off by heart. So what I do is use a formatting style guide and use that to ensure that I'm adhering to it. And also, much of what I do is automated in R and R Markdown. And so what that means is that it outputs things for me automatically. But it's a good skill to be able to know so that you can verify that the output is correct. So that's useful to know. Excellent. So that is APA formatting. Okay, now I'm going to take you through to using syntax and R. So let me pull up something. Should we name the tables table 1, table 2, etc. at the bottom of the table? I think that's good practice. It is useful to number your tables. I think what would be nice is to call it table 1. So I could do something like this. and say table 1. And then I'm not sure if it needs to be, again, this is where you need to check if it needs to be italicized or not. And then, yeah, give it the title and whatnot. So, yeah, I think that's good practice there, Shivani. So well done. Cool. So that is that. Let me pull up. No worries. Let me pull up Jamovi. Okay. So let me remove that. Okay. So what I'm going to show you now is, I said before that Jamovi is like a gateway drug to R, and let me explain that in more detail. So this is, oh wait, where are we? Let me put this in the screen here. Okay. So this is, if I can get it to come up. There we go. Okay. So this is RStudio. Yeah. And RStudio is what's called, it's a way to interact with R. Yeah. So this is what an R console looks like. So R is really a programming language which allows you to do every analysis you're doing in Jamovi, you'd be able to do here in R. So fundamentally, you can use it as a calculator. You can say 5 plus 2 equals, and it returns 7. You can assign numbers to variables. So this is me assigning the number 5 to A. And then if I select A, it'll return 5. I can assign the number 2 to B. And if I press B, it returns 2. And if I start adding those variables together, it gives me the number, as if I actually added the numbers. And so you can assign a full data set to this as well. And so what is cool about Jamovi is it's built on the top of R, and it also allows you to see the back-end code. So if you go into and select syntax mode, so you select those 3 dots, and then you select syntax mode, it actually allows you to see the data, the code that you need to generate these sort of plots and tables. And so I, in my slides, which you'll have access to, provided you with the sort of things you'll need to do to be able to start using Jamovi in R. And so let me explain to you the framework of what this is and how it works. So in R, you can think of it as analogous to buying a mobile phone. So when you buy a mobile phone, you have base functionality in that mobile phone. You can start calling people, you can start texting people, but if you want to actually access an app like Instagram, or I play chess a lot, so if I wanted to play chess on my phone, I wouldn't be able to do that with the base functionality of the phone. I would need to go to Google Play Store or Apple Store. I need to download chess.com as the app, and then I would need to load it, right? So here, the install packages in R is the equivalent of going to your app store and installing the app. And then it's on your phone, but you don't always have access to it. So if you want to access it, that's where you do library JMV, and that opens up the Jamovi application. So that's what you'd need to do. So here, that's what we will do. So I'll go into R, which is here within RStudio, and I'll say install packages JMV. So that's installing the Jamovi package. So you can think of it as going to the App Store, installed it on my phone, but it's not really opened yet. So I need to open it through library. And I go JMV, and it's very anticlimactic because that's all that happens. You don't see any error. So because I've run that line of code, it's there. So that's excellent. And that has shown me that I've now loaded Jamovi. So I need to do one more thing before I can start copying all of this syntax into Jamovi, which is I need to load the data file because R doesn't see the data file. So to do so, I need to call a variable called data, and then I need to read in the data file, which is in this case a CSV, and I would need to type in where that data file is. So that data file is located in this path. I need to put a first dash. So it depends where you locate your data file. So you could, so this is sort of the structure of the documents I have on my desktop. So here's an insight into the madness of my folder structure, or maybe the genius, who knows? So 7126, and then 2026, and tutorials, and then we go data tutorial 1 Jamovi data. Okay, so that allows you to read in the CSV file for the data. So that's now loaded the data. So if you look into this environment here, it shows you that you have a data set with 109 observations and 26 variables. What does that 109 observations relate to in our data set? Does anyone know? Countries, well done, Luella. So the rows, yeah, and typically participants, you're right, Rochelle. So if you go into here, and if you scroll all the way down, you'll see you have 109 rows of data, right? And that is what we see in RStudio. So that's what the 109 here corresponds to, right? So now we've downloaded the app from the App Store, which is Jamovi. We've loaded it so we can actually use it. And then we've loaded our data. So now, once you've done those 3 steps, you can now start copying this Jamovi syntax into RStudio. You can paste it and you can run it. And it will give you stuff, exactly what you saw in the Jamovi package, right? So it shows you the table. Oh, great. Thanks, Luella, for the positive response. And it shows you the density plot here, right? So it maps the plot. Now, you can learn how to use it within R itself, but you don't actually need the Jamovi package to do these things. R has ways of doing it. Let me see if this works. If I plot data life expectancy males, does that work? Yeah, it plots it in this way. If I say hist data life expectancy of males, right? So these 2 lines of code are like the ways in which I'm using the base R. I'm not using any package here, but this is using the Jamovi package to generate the same thing. You can see how this histogram of life expectancy of males is in some ways pretty much the same as this density plot here, right? It's just showing it in different versions, right? So there are ways in which you can code, so it allows you to use Jamovi as sort of a friendly introduction into that scene. And so when you make changes here, if you bring across more data, yeah, you can just it updates automatically. You copy that across into R, and it'll load it accordingly for you. Yeah, so that's the table that's there. Why is this so beneficial? Well, I was saying the thing with Jamovi that you'll learn pretty quickly is the fact that it's point-and-click software. So what that means is the fact that every time you need to do something, if I was to close down Jamovi, I'd have to open it up, load the data file, and then I'd need to select the buttons. I'd need to choose the descriptive statistics. In R, you have something which is, you can create sort of like a Word document, or it can be an R script if you like. And this can store your code in it. So for example, let me include the code I've written so far. So if I write that in there, install packages, and then library is the next one, and then the data file is here, and then I do something, and then I do here, which is the Jamovi description. And let me just delete these points here. So if you have this here, this is like your data analysis in a Word document. And so Jamovi allows you to save this as like as your coding document, like a Word document. So then the next day, if you open up your data analysis and you want to say, hey, I'd love to see those plots of those descriptives, you actually just click run. and it runs all of that for you. Or you could run individual lines of code and then get it done. So with the click of a button, you can rerun all your analyses instead of individually selecting each analysis that you need to do. Like if I closed all of Jamovi down and I needed to do it again, I'd need to go into analyses, exploration, descriptives. I need to pull across the variables, make the selections that I need to make, and go from there. So this allows you to make your analyses reproducible. So in many years ago, and maybe to some extent still to this day, people had the philosophy of, oh, don't worry about how I do my analyses. I do it. You can trust me. I do it correctly. And researchers realize that even with good intentions, people make mistakes. It's just the nature of human error. The beauty of something like this is you can sit down and you can see exactly the steps I did and what happened and whether there are any errors in that process. But if I was to sit down at your Jamovi file, I wouldn't necessarily know how you got to where you got to with the outputs, or what steps you did, or what changes you made. In R, it allows you to record those changes in a detailed manner, like a recipe book or a script. So it can be really useful in those manners. You don't need to use R to succeed in this course. This course is entirely built off of Jamovi, but I wouldn't be doing my job as a teacher if I didn't show you how you could start learning to use R, because R is one of the key skills that many employers are looking for. As you graduate as a psychologist in this undergraduate degree, you will then have the capabilities of not only your psychology knowledge, but your statistics. If you add something like learning R to that, you'll maximize your employment opportunities. And so this is really critical, and it's a good way to plug the DataCamp site that's on Canvas. I applied for a DataCamp classroom for everyone to use. So for 6 months or a few months of this year, using your university account, you will have access to DataCamp courses. So if you want to learn R further, there's Introduction to R courses. If you want additional supplementary materials for learning about correlations or regressions, you can go on DataCamp and see what they have available and learn a bit more about each of those contents. So that's just, again, it's a sort of additional supplement. It's not the core focus, but I just wanted to, I wouldn't be doing my job if I didn't show you what was possible. And so that is how you can use Jamovi, built on the back end of R there, to do all your analyses. Excellent. Any questions about any of that? Let me know in the chat if you have any questions. So yeah, I think I gave you the spiel anyway, so you have a good sense of the power and utility of R. You can save your syntax easily, store, modify, and rerun your commands. You can have a record of what analyses you've done, and in Jamovi, it allows you to do that with the syntax button. So you, again, as a reminder, you go in here, 3 dots, and you click syntax mode for that. There is an R module. You can go into modules. In the same logic I said of installing packages in R, you can install packages in Jamovi. It's a Jamovi library, and install the R module. But I think it's easier if you were to use R within RStudio, because even I struggle as an expert R user in using the Jamovi version. So I think using R is better, because it also allows you to save the script, which, as far as I'm aware, you can't do in Jamovi. Excellent. So that is that. Now, again, I just want to emphasize, you're not expected to use syntax in this step. There are some things we do in syntax in this course, so it can be useful to get used to looking at it. But beyond what we've just done, you really won't have to know more, and you can succeed in this course without knowing any R. But I just think it's important to know that skill is available for you to learn in this unit if you like, or even beyond. Excellent. So that is everything there with syntax and R. If you have any questions, pop them in the chat. Otherwise, we'll get into data shaping. So data shaping is the process of renaming variables, creating variables, inputting data, and recoding or transforming variables. So we're going to be going through this process together now. So let's do that. So what I want you to do is to rename the variable population to population, or like this variable without the ION into ION. So double click, go into your data file, double click population, and change it, add an IO. there. And then I want you to add a description. So say number of people living in each country. Yeah. And the next thing I want you to do is click. Oh yeah, sorry, no, we've already done that. So we clicked into the description field and entered the description. Now I want you to have a go at naming, creating a variable. All right, so you can click anywhere on this list, right-click any variable, go to Add Variable, and select Append. So that will pop a variable at the very end of your data set. Now, I'll be honest, the first time I used Jamovi, I was like, oh, wow, it has like data about me because it knows my initials are AA and use that for the variable name. That is not the case. You also have AA, despite having AA as your, may not have AA as your initials. So that's just the nature of how it's named. So it's AA, then AB for additional variables. But I learned that over time. So so let's create a variable. Let's call it something. Does anyone have an idea for what variable we could put it as? Any ideas? Maybe we could do something like, I don't know if number of children is there. Must be due to my special import. Yeah, thanks, Emery. Yeah, I agree. I think so. Look, I'll put number of children. And then this is average number of children per family, or maybe per person. Excellent. So I've given the measure a name, so it's number of children. I've given it a descriptor. I'm going to put in some numbers here. So 2, 3, 1, 3, 4. Oh, 65 is a lot. Let me go. I'll go 8. So this is just giving you a sense of what it is like to put in data in Jamovi. So have a go at doing that, putting in data. And for the assessment, this is useful because you'll be populating the data file yourself. So you'll be populating it with numbers. That's how it works. Now this is number of children. Is it ordinal or continuous? Yeah, you could argue it's largely continuous, right? So you have these numbers on a scale, so 1, 2, 3, 4, and it goes on, and it means something to have 0 children as well. It is integer, and it's all there. Excellent. So we've created that variable there for us. That's excellent. So well done. Hopefully you've done that okay as well. What is next? All right. So and we've done the measure type, and we've done the data type. And yeah, you hopefully have a good sense of level of measurement, which we'll be hammering in further in the lectures. So now I want you to add a case. So we've added some data. Now I want you to add a case. So to select anywhere, and I'm going to insert a row. I want 1 row. I'm going to have a country. The country is called the University of Canberra. Why do I have underscores here? Because I thought that fixed the error that I had before. Okay, clearly not. I thought underscores prevented this from happening, which is where it loses all the data, but clearly not. Now, what do I do? So any recommendations as to what I can do now that I've lost all the data in country? Control Z, that's a good instinct, Llewellyn. When I do Control Z, that does not seem to return the country data. I'm on a Mac at least. So at this stage, this is where you just, you have a little moment to yourself, you break down, have a bit of a cry, change the text. Oh, Llewellyn, that's a better option. Let me try. So let me double Control Z. Yeah, let me double it. No, it's just deleting the variables I put in there. Changing to text, that I don't think that'll work either, but we'll give it a go. So it's pretty much lost. I've made an error. I've done something. I pressed enter after putting in stuff, and it went. So what do you do when you play around with data and this happens? If you go to the data, there will be undo button. Oh, I did not know that. Oh yeah, but that is the same as what was occurring before Annalise. But thank you. That's a fair guess. So it's pretty much gone, and so I've broken the data set. So what I need to do is I just import again, right? So you just go into I would close this, don't save. I would open up Jamovi, right? And then I just import again. Maybe I don't deserve the special import after that error. So let me just go into here, tutorials, data, tutorial 1, Jamovi file. Boom. Excellent. Oh, interesting. In that version, it takes away the AVC as well for you. So that's useful to know. So this is a good lesson in the sense that if you have a data file that you're working on, and when you save, if you're doing changes to that data file, you should save it as a new file so that you can always build from scratch from the raw data. If you're editing over the raw data file, then if you encounter an issue like I encountered there, then you won't ever be able to get this data back. So for your lab report, that's good practice, but keeping in mind that the data file is going to be made available on Canvas. So that's sort of where your base file is that you can download. For mine, if something is deleted or broken, if you Control Z once, it goes to the section, then do it again and it fixes it. Mel, clearly, maybe you deserve the special import because my computer did not let me do that. Mel, out of interest, are you on a Mac or a Windows? Let me know in the comments because that could Windows. Interesting. I'm on a Mac, so maybe that's a distinction as well in terms of what's possible. I'm not sure. Excellent. So that is everything with that. We were doing? We were entering data into a cell, yeah, and then it all broke. So let me enter that data in. So you go insert row 1, and then insert it here. University of Canberra. I won't press enter. I'll just move on to the next, and then you can keep inputting in numbers, and you get a sense of what it's like to have your data imported there. Yeah, it's weird you can't use spaces if some of the country names already have spaces. That's a good observation, Luella. I think you're right that you could probably use spaces. I'm probably fine to use spaces. I'm going to try and do it. I think the issue was I just pressed enter. So let me see if you're correct. Yeah, you can use spaces. Yeah, you're fine with spaces. Yeah, you're right. So there's no need, because all the rest of the countries have spaces, you're fine to use spaces. So it's all text. So, or here it's called ID, but you're right. So excellent. Thank you. That is that. Now what we'll do, we enter data, we've selected the desired cell. Okay, let's delete that cell now and delete our variable. So here, I want to delete this, so I select the cell or select the row. If you want to delete the cell itself, you just select the cell and select delete, or select the cell and select backspace, both will work. And then to delete the row, you select the row, right click, and delete row. Do I want to delete? I am sure. And then if I want to delete a variable I didn't create, right click and delete variable. It's not there for me. Yeah, excellent. Okay, that is that with inputting data. What we're going to do now is everyone's going to get a 5-minute break. Stretch your legs, go get a tea, and then we'll regroup in at 36 past. Go to the toilet if you need, and then we'll get moving on with the data shaping. Yeah. If you have any questions in the meantime, pop them in the chat. I'm going to get some more water. I'll see you guys very soon. All right, guys, let's get back to it. Some questions that came through in the chat during the break, which I've responded, but just recording for people listening, is it was noted apparently these online tutorials are scheduled for 1 hour. All tutorials in this unit are 2 hours in length, and that's just because of the depth required to cover the content, and when people have lots of questions, especially with coding and programming and analyses, 2 hours is really the time, and that's why they're fortnightly tutorials as well. So no worries, that's all good. It seems like many people in the chat thought it was an hour, so it is a 2 hour tutorial here, so no stress at all. And the asynchronous one is the recording of this one, so you'll still have access to it. So if you can't attend the next hour, don't stress. This will be popped up with the slides as soon as the recording is finished. So that's that. And then the other question, yeah, no, those are the two questions. Excellent. Okay. Great, everyone ready? Let's get back into it with the data shaping. So we've deleted the variable. Now what we're going to do is talk about recoding. So what I want you to do is have a look at these items, which people rate their agreement from strongly disagree to strongly agree in relation to climate change is real, climate change is caused by humans, and climate change is a hoax. If we created an average of people's response to these items, what are we measuring? Or what are the challenges that occur if you create an average of these three items? Does anyone have an idea? An invalid data set. Well, look, in some ways it's misrepresented, but what is the problem that we have here? Imagine someone with extreme views or beliefs. What would the average look like? Outliers might give us a less reliable view of everyone's views. Well, actually, yeah, in some ways, but that's not by them being outliers. It's actually by nature of the questions themselves. So think of someone who, yeah, exactly. Well, they would actually average each other out. So that's essentially it. So if you think of someone who says climate change is real and they report strongly agree, a 5. Climate change is caused by humans, they say 3. Climate change is a hoax, they say 1. Right? Strongly disagree. If you average those numbers, you get 3. Whereas that's not necessarily reflective of the belief of the person here. It's because climate change is real and climate change is a hoax are sort of opposite questions when you're looking at this scale. So you need a reverse code to make sure that they're all pointing in the same direction. So you could reverse code an item to say that higher scores mean stronger belief in climate change being real, and lower scores are climate change not being real. So that's the issue that happens with questions such as this. So it's important to be able to reverse code variables to allow for that. So how do we address this question? So if we want to reverse code the urban variable, right now, higher scores mean more urban. And so what we want to do is reverse code that variable. So higher scores mean more rural. So we go into our data set, we find urban. Oh, sorry. Find urban, right click, go into transform and select that. And you'll notice it creates automatically the identical variable next to it. So all these changes happen to the transformed identical variable. So it's called urban2 for now. So we'll use transformation. There's no transformation yet. So we'll create a new transformation. And this will be called reverse code 1 to 100. Or I'll call it reverse code urban. Reverse codes data on scale of 0 to 100, because I think the values are 0 to 100 here. And the variable suffix I'm going to call R100. Why is the suffix important, or what does it do? The suffix gives you a little automatic change to the variable name. So if you were to open up this data again, and you're saying, oh, look, what's called what? Why is this called urban twice? the suffix tells you, oh, this is the transform variable and this is not. So having something meaningful there is important. And then, so we've done the transform naming. We've named the transformation, added a description, we've added a suffix. So now we need to add a transformation rule. The variable goes from 0 to 100. So there are 100 points in the scale, and it begins at 0. So the transformation would actually be 100 minus the source. And we can double check it, right? So here, higher scores meant more urban. Now here, higher scores mean more rural. And so if it's 18, that becomes 82, which makes sense. 100 minus 18 is 82. 86 becomes 14. 68 becomes 32. 85 becomes 15. So it looks like our transformations work correctly. And that's pretty much how you would transform a variable. Yeah. Now, any questions at all about that? No, all makes sense. What I'm going to do now is I'm going to give you an activity. Luella, yeah, go for it.
Under the add recode condition, it says if source, and yours doesn't say that, so I'm wondering what's went wrong.
Under where? Under this, where?
Under the reverse code.
Yeah.
It says add recode condition, and it says if source.
Okay. Yeah, that's if you want to do some more complicated coding to apply the transformations to maybe certain rows. And we'll actually cover some of this in later tutorials as these if conditions, how to use it to select the data. But for now, we're just gonna press X and apply it to every single row. So that's the recode condition. Yeah?
Okay, thank you.
So no worries, all good, Luella. Cool. So that is that. Like categorize it. Mel says like categorizing 0 to 50 is low, 50 to 100 is medium, and 100 greater is high. Yeah, you could do something like that, Mel. Or you could perhaps you wanna only recode those that are less than 50, and so you could apply the recoding condition for if it's less than 50. Apply it there. Yeah. Excellent. So there's all sorts of conditions, and we can go through that. But really, for now, for what you'll need in at this stage, I think understanding how to do these transformations is the key, and then we can build complexity with the recoding conditions. Excellent. That is that. So what I want to do, I wanted to give you an activity. So I want you to create a new variable. So go click on the data set, add variable, insert variable, and I want you to type in random numbers from 1 to 5. Oh, can I do that? What's happened? Add variable, insert. Huh, I cannot type in numbers. Oh, there we go. I have to double click. Okay. That's strange. What if I appended? Does that change? Oh, I don't know why I'm needing to double click now, but that's what I need to do apparently. So I want you to go through each of these cells and put a number 1 to 5 in. Yeah, I'll delete that one. I'll delete that. Okay. So has everyone had a go at that? Put in the numbers 1 to 5. This doesn't need to be exactly like mine, just needs to be numbers in 1 to 5 range. What my task is for you is I'm going to give you 5 minutes. I want you to try to recode these numbers using a transformation so that the 1s become 5s and the 2s becomes 4s and the 3s become or stay as 3s and the 4 becomes 2, 5 become 1. So use a transformation and reverse code these so that it's coded in the opposite end of the scale. have a go. Let me know in the chat if you're having any issues, and pop your hand up once you're done. If not, I'll just give you 5 minutes to have a crack at that. How'd we go, guys? Did anyone find any challenges with doing that activity? Yeah, good job. Look, with this one, the trick here is, and hopefully you're all able to navigate it okay. What changed between the previous transformation and this transformation? So you set up transform, create new transformation. What did you do differently in this source condition? Yeah, excellent. So you wrote 6, right? Excellent, Lola. So in the previous example, it was 0 to 100, so you just wrote 100. But here, if you wrote 5, you would notice that you wouldn't get the transformation you're looking for. The 1s become 4s instead of 5s, and the 2s become 3s and whatnot. So we want them to be reverse coded properly. So because it starts at a 1, you have to write 6. And same thing, logic. If you were 1 to 7 is the scale, then you would subtract the values from 8. So you just add 1 and subtract, and that allows you to get the scale. So that's only when it starts at 1. Yeah, excellent. Well done on getting that. Sometimes that can be tricky to navigate, but that's important to remember when you're recoding variables. Why do we recode variables? To ensure that they all point in the same direction. Okay, now we're going to look at saving your work. So to save your work, click on the 3 horizontal lines in the top left of the screen and save as OMV. So your file. Remember, save as, because the first time we don't want to save over our main data file. So you go save as, and then you save it in whatever format you want to save it as. So that is how you save your data. And here I've just hammered it home again. Best practice, save data as a new file rather than modifying the original. Yeah. Any questions about any of that content? All good? Yeah? Excellent. All right. So I thought I'd use this as an analogy for coding. And this is my friend who was on a trip to Blue Mountains, and he survived this. He's doing okay. And you can see there's a red line. That's the rope that's being used to help him get up that wall. And in rock climbing, which is an activity I like to do, I think there's a lot of analogies between rock climbing and coding, in the sense that you need to be able, in rock climbing, you have this problem, which is the wall, and you're trying to be able to get up the top of the wall. There's lots of different solutions. You can identify different handholds, different footholds, each have different strengths and limitations. In the same way, when you're using Jamovi, you may be using a different version of Jamovi, you may be using it on a different computer, you may have different ways of getting to the same answer using the editor in R or using Jamovi. It's all really about playing and being able to get your hands dirty into the data, so that you get a sense of, and the software package, so you get a sense of how to do these things. And fundamentally, you want to get to the stage where when you're working in Jamovi, you're able to select exactly what you need straight away, so that it's really a function of an automated process that you're saying, okay, I need to run a correlation, this is how I do it. Or I need descriptives, this is how I do it. Or I need a frequency table, that's what the buttons I need to click. The more you're spending time trying to work out the mechanics of how to do it, the more challenging it can be to be able to run the analyses efficiently. And so, and this is of particular relevance when it comes to things like the final exam, which does involve some Jamovi use, a lot of Jamovi analyses. And so I really encourage you to have a play with Jamovi, have fun with it, and play around with the data. So there's lots of free, openly accessible data sets that are available online. There's nothing stopping you from downloading those data sets and seeing if you can transform some of the variables, add some numbers into it, or see if you can change the descriptors of those variables. and do some of the things that we've learned today, and just to explore what you can do with those data, different visualizations that are possible. And then, of course, if you're interested, you can always explore using R, but as I emphasized, that's not critical for this course, but just another avenue that you could pursue. Excellent. In saying that, if you have any questions at all, you can always ask them on the discussion forum. There are two forums, one for Jamovi. So if you have questions about your Jamovi version itself, or things aren't working in Jamovi, let me know. If you have things about the tutorial content, you can pop that in the tutorial discussion forum. And it's good to first identify the discussion forum in relation to your post. Look through that forum to see if it's been asked already, and if not, post in your question in relation to what you have, and that will ensure that others who have similar questions about Jamovi, they'll go to the right place and be able to find the answers that are there. So it's really a synthesized place for questions and answers. But in saying that, that's it for today, guys. So I hope you had a lot of fun with the intro to Jamovi. Keep playing, keep exploring, have a lovely day, lovely week, and I'll see you guys at the next tutorial, which is in 2 weeks' time, and I believe it's on a Wednesday. Excellent. I'm glad you guys got a lot of value out of it, so thanks for letting me know. Have a lovely night. I'll see you guys in 2 weeks' time. Oh, sorry, the online tutorial will be on Thursday still in 2 weeks. So your calendar says it all, but I know their scheduling's had some issues at the university, but that's the key thing to remember. Excellent. Yeah, good to hear, Emery. Excellent. See you guys. Have a lovely week.